Given a standing wave with a wavelength of 20 centimeters, if the origin is a node, where are the nodes and antinodes? And maybe I should have said where are the other nodes in addition to the origin and all the antinodes. Let's draw a picture of this to see what we're being asked about here. So I'm going to try to sketch a standing wave. It's often hard for me to do it in a way that it's all like regular, like a wave really would be. I'm going to try to at least get a few parts of it. Maybe that's good enough there. And then this is the part I'm really going to struggle with, is I'm going to try to get the other extreme here. And it's probably not going to be perfect. But based on this, we can identify things like nodes and antinodes and look at, like, how do we use this information about the wavelength? Well, it says the origin is a node. So maybe I'll just arbitrarily decide that this node right here, let's make that one the origin right there. And then we're told that the wavelength is 20 centimeters. Well, for an ordinary traveling wave, the wavelength is the distance crest to crest, and that winds up working for a standing wave as well. So that means this distance here all the way over to this other crest over here, that is an example right there of one wavelength. So we can label that with the 20 centimeters that were given. But we were just told that this is the origin. Then we're asked for where are the other nodes and where are the antinodes. Well, given that from crest to crest is 20 centimeters, it might make sense that from this node, and then I'm going to skip this one and go all the way to this one, that looks like it's roughly a wavelength. So this next node here would be at the 20 centimeter spot on the number line that I'm kind of haven't drawn, it's invisible, but that I'm working with. And this node that is halfway between there, I think that would correspond to 10 centimeters. So you can see I can find quite a few of them because it looks like the nodes are happening at 10 centimeter intervals. So there'd be another one here at 30 centimeters. And now let's look at the antinodes. Well, if from the origin to here is 10 centimeters, that's 0 to 10. And if an antinode, is halfway in between that, then that spot right there should correspond to 5 centimeters. And the next antinode would be right here, and that would be 15 centimeters. And then there'd be an antinode here. So it continues in 10 centimeter increments. 10 centimeters between each antinode, just as there was 10 centimeters between each node. So at least I found a few of them there. You might say, well, how do I list all of them, right? Am I going to have to find all of them? Let's look at the answer in the example, and we can see what it does there and see if that reconciles with the picture. It says nodes are at x equals 0, plus or minus 10 centimeters, plus or minus 20 centimeters, plus or minus 30 centimeters, and so on. I think that captures the idea, right? Because when I looked at the nodes that I identified, they were at 10, 20, 30. What I forgot to say is, there's another one over here at minus 10, and there'd be another one at minus 20, and so on. So those plus or minuses take care of that. And then for the antinodes, I had said 5, 15, and 25 centimeters respectively, but just as with the nodes, there's going to be negative antinodes or negative located antinodes. So there's going to be one here at minus 5 right there, and then there'd be one somewhere getting close to the edge of the whiteboard there at minus 15, and so on. So the way this answer stated here, I believe, captures all of that information.